In this lesson, we're going to look at linear programming. For the most part, you're going to be looking for a maximum or a minimum of a region from when you were graphing it. Now, in our last lesson, we ended up finishing the last problem with three inequalities and looking only where they overlapped and it formed a triangle, and we were looking for our corner points. Essentially, we're going to have to do that here too. And then we're going to have one additional step to be able to find our max or min. So we're going to start out with these three inequalities, and we're going to have to graph those. Once we have that, we're going to have to find our corner points. That's why it's nice to have an accurate graph. Then we're going to have to plug those corner points, those vertices, into this function right here to find our max or min. So x is less than or equal to 5. Less than or equal to 5 for x. That's going to then be a vertical line. And then you're going to have to shade everything to the left because x is less than. Because your x goes left and right, and to the left of 5 are the smaller parts. Y less than or equal to 4 means you're going to have a horizontal line at a height of 4, and then you're going to be shading below that because all your y is for less than 4 is below that because y goes up and down, and so the smaller ones are below. This one here, we want to go ahead and get y by itself. So we'll go ahead and subtract x from both sides. So we're going to have a diagonal line starting at a height of 2, and then we're going to have a slope of -1, so down 1 over 1, down 1 over 1, and so on. So if we graph that, we just get this. Here's our blue diagonal line. Here's our vertical line. Here's our horizontal line. We can easily find our corner points. Now we want to take those corner points and make ourselves a table. Now normally you're just making an XY table, but we need to add another column here for our function. So I'm going to put my corner points, the -2, 4, the top left corner point. Then I'll put down my 5, -3, the lower right corner point, and then I'll put my last corner point, the upper right one of 5, 4. The order in which you put them in here doesn't make a difference, but make sure you have this point here matching with this point here, or coordinates matching because they go to the same point. So now we need to plug it into our function, which is 3 times your x minus 2 times your y. So I'll take 3 times my x coordinate minus 2 times my y coordinate, and then that gives me -14 because I get a -6 minus 8. Plug this x in, plug this y in into my function. So I get 3 times 5 minus 2 times -3. So I get 15 plus 6, which is 21. And then I'll plug in the 5, 4. So 3 times 5, which we know is 15, minus 2 times 4, which is 8. And 15 minus 8 is 7. And according to our problem, we were looking for the maximum and the minimum. Well, when you look at your output here, the largest is 21, so that's going to be your maximum. So we're going to say our maximum is 21. When does that occur? At the coordinates of 5, -3. The smallest of these would be our minimum, so that's the -14. So we'd say our minimum is -14. And when does that occur? At -2, 4. So that's linear programming. Now, a lot of times your problems are going to be given to you. Well, I shouldn't say a lot of times, but some of the times your problems are going to be given to you just in one word problem. So first of all, you're going to have to read it, and maybe read it multiple times. Then you're going to have to figure out what you're going to use for your inequalities or your variables, and then you're going to want to write your inequalities using those variables. Then it's just like the last lesson of graphing those inequalities and finding the corner points, and then you have to do that one extra step of making that table to find your maximum and minimum. And then you got to answer the question that's being asked.
Bob Walbrook.
So here's our basic question. So take some time to read through it. Probably read through it at least 3 times, and then underline some of the key things, and maybe even underline the key things that go together. So pause the video and do that. So what I have done here is I've kind of highlighted some of the key things that go together. We have 1 hour for mowing jobs here, 3 hours for mowing jobs here, and we know we have a total of 9 hours a day. So those go together. And then here we're charging for mowing the lawn. Here we're charging for shrubbery, and we're looking for maximum income, which is money. So we know the purple things are going to be going together. We also have a restriction here of no more than 2 pruning jobs. Now we're trying to find the combination of mowing and pruning jobs that will maximize our income. So the 2 unknowns are the 2 yellow things. So I'm going to choose variables to represent those 2 things. So I'm going to let M represent the number of hours we spend mowing. P, the number of pruning jobs. Well, if that's in mind, we automatically know a couple of inequalities. We know M is going to be greater than or equal to 0 because you can't have a negative number of mowing jobs. Consequently, we know we're going to also have P greater than or equal to 0 because you can't have a negative number of pruning jobs. Now, this gray thing deals with pruning jobs. So that means that P for our pruning has to be less than or equal to 2 since there's no more than 2 pruning jobs. So we have 3 inequalities already. The first 2 were really easy. The second one wasn't too bad. But now we have another restriction. Typically anything up here that's going to be a restriction is going to help you with one of your inequalities. That's what the gray was. But we also have another restriction here with a maximum of 9 hours a day. So we're going to have another inequalities where the hours we spend mowing and the hours we spend pruning have to be less than or equal to 9 according to what it's saying here, because you can't work more than 9. Well, it's 1 hour for each mowing job and 3 hours for the pruning jobs. So it's really 1 times your mowing jobs plus 3 for each pruning job, because that's going to tell you your total number of hours. Because if you had 2 pruning jobs, it would be 2 times 3 for a total of 6 hours. Now, for the sake of graphing this, I like to use y equals mx plus b, but we're not dealing with x and y, so I'm going to just choose one of the variables to get by themselves. And I'm going to choose to get p by itself. So p is going to kind of be like my y value. So I'm going to have that on my vertical axis because when I get it in the form of y equals mx plus b, what's over here typically corresponds to the vertical axis. And then this would be like my x, so that'll be my horizontal axis. So if I have m and p both being greater than or equal to 0, that means I'm just going to be in the first quadrant. So I'm not going to have anything to the left, and I'm not going to have anything to the right, just in the first quadrant. So that's what those 2 do. Now, this one here, since we have p by itself, our slope is negative 1/3, our y-intercept is 3. So I'll start out up here at a height of 3, then down 1 over 3, down 1 over 3, down 1 over 3, and I can graph that, and I'm be shading below. Now we also have this horizontal line. It says p is less than or equal to 2. Well, here's a height of p being 2. We want all those, so all these have p being 2 going across here, and we want to be below that. Now sometimes when you're graphing this, you could just choose a point to figure out which region or which side you're shading on. And you could do that by just making yourself a t-chart for this, getting your 2 main points for your intercepts and graphing it, and then you can choose a point. Because if I would choose a point like 2, 1, and plug it into the blue here, it would make it a true statement. So that means I would have to shade on this side of the blue. So now shading where all 4 of these overlap, I then want to write down my corner points, which I have right here. And I want to put those corner points in my chart. Now, for the income up here in purple, that's what we're trying to maximize. That allows me to figure out this, because it's $40 for each mowing job, plus $120 for each pruning job, and that's my income. So I'm going to take my corner points, put them in my chart, and then plug each one of my corner points into the function, in this case, that I'm trying to maximize. Sometimes you be trying to minimize, but it says we're trying to maximize. So we plug in 0, plug in 0. Well, of course, if you don't have any work to do, you're not going to be making any money. So we kind of knew from the beginning that that one wouldn't work. Plug in 0 for the mowing, plug in 2 for the pruning, and we get 140. Plug in 3 for the mowing, 2 for the pruning, we get 360. And here we plug in 9 for the mowing, plug in 0 for the pruning, and we also get 360. Now, since we're looking for a maximum, we actually have 2 different maximums that work here for us. Normally, you're not going to have that. So, we're looking for the maximum income. Well, our maximum income is the largest, which is 360. And in this case, that can be accomplished 3 different ways. So you're going to say your maximum income is 360 ways, from either 3 mowing jobs and 2 pruning jobs, or from just 9 mowing jobs.